notes, so I just use them. These are not my notes. All right, so logarithm functions, log of base a of x is equal to y if and only if x is equal to a of exponent y. When a is greater than 0, x is greater than 0, you go from logarithmic to exponential. So for the very first problem, write the logarithm equation as exponential. There's a lot of things you could say. The most common one is like around the world. So you take that 3. It's equal to 81, and you bring it to the power of what that log is equal to. So in this case, it's equal to 4. So you take the base and you write it to the exponent of 4. So you could actually double check if you did it right. 3 to the power of 4 is indeed 81. So that is logarithm to exponential. And you should be able to know how to do it going backwards, going for exponential to logarithmic. You take this to 8 and you bring it to the base of it. So log base of 8 of 64. 8 is the base of, so there's one thing you could do. So this is the base of the exponent. And this 8 is the base of the logarithm. So that's a little hint to help you guys. Base of the exponent, base of the logarithm. So those don't change. Evaluate the function at the indicated value of x without using a calculator. And so we're going to solve this equation without a calculator. So in this case, f of 1/4 is equal to log of 16th of 1/4. So to do this problem, you could just write y is equal to log of 16 of 1/4, and all you have to do is just convert it from logarithmic to exponential. So this would be 16 to the power of y is equal to 1/4. Now there's a lot of ways you could go about it. Honestly, you have to know your what's it called, your rules of exponents. So for example, how do I convert 1/4 to a integer? Do you guys remember how to convert fractions into integers? What do you guys have to rewrite it to? How do you convert 1/4 into an integer? Not everyone at once. 4 to the power of -1. Both of these have a common base of 4. I convert that 16 to 4 squared, right? Isn't that 4? So then you use the property of exponents. You have an exponent times an exponent. So that's just 4 2y for -y. Once you have the same base, you cancel them out. 2y is equal to -1. Y is -1/2. So that's how you solve these problems without using a calculator. You kind of have to use your conversions of exponents. Does anyone have any questions? Okay. So the properties of logarithms. So log base of a is equal to 0 because a to the power of 0 is 1. Log base of a is equal to 1 because a sub 1 is equal to a. Log base of a to the power of x is equal to x. This one is pretty much using the power rule of exponents. So it's pretty much taking this log base of a and you're moving it up to the exponent. So you're moving it all the way up here. So that log base of a is now log base of a over x here. So you're kind of using the power rule. You might see this, but not a lot. But it's a pretty nifty rule. And then this one, if the log base of a of x is equal to log base of a is equal to y, then x is equal to y. So if they both have the same bases, they're equal to each other. So you're going to need to know how to use these properties to solve for values without using a calculator. Now, it's not going to be for all the problems, but for majority of the problems, especially the ones on your test, it's going to ask you to solve them without the use of a calculator. Now, you can use the calculator to check if you did the problem correctly, but you can't use the calculator to actually solve the problem. So just make sure you read the questions. For this problem, it says solve the equation for x. So all we have to do is convert from logarithm to exponential. So this is 5 is equal to 5 to the power of x. Both of these have the same basis. Does anyone know what this exponent of 5 is? Very good. There's always an imaginary one. So now that the bases are exactly the same, 1 is equal to x. So x is equal to 1. So that is my answer. Common base rules, same bases, cancel them out, equal the exponents. Number 28, log base of 2 to the power of -1. So log to exponential, 2 -1 is equal to 2 to the power of x. They have the same basis. -1 is equal to x, and that's my solution. So pretty easy, not too difficult. Just remember the old rules. So log base of 3 of x, log base of 3 to the power 4. They both have the same logarithm base. They can cancel. X is equal to 3 to the power 4, which in this case is 81. And that would be your answer. So knowing all the previous rules. Does anyone have any questions? So
The next section, I want to see it.
what's the next section?
Graph.
Oh man, I hate graphic. Inverse functions are found by switching x and y. So it's not too difficult. It is annoying though. So a couple of properties of log-based functions when graphing when a is greater than or equal to 0, but a can equal -1. So the domain is 0 to infinity. The range is -infinity to positive infinity. It has an intercept of 1, 0. It increases from 0 to infinity. And there's an asymptote at the y-axis. And here's a picture of it. So remember, log-based functions are inverse function of exponential. We'll learn exponential to next week. So remember, this has a intercept at 1, 0, and it's increasing with a asymptote at x equals 0. Okay, so let's get to the problem. So here's the thing, when you are for sure going to get one of these problems on your test, you're gonna have to solve it by hand. You're not gonna be able to solve it by using Desmos, even though you can use Desmos to help you with the homework. It's not gonna help you on the test. So you should all know how to solve these problems. So you're gonna find the domain, the vertical asymptote, the x-intercept, the logarithm function, and the sketch by hand. So we're gonna do them one by one. So the first thing you want to do when you convert, when you have a logarithm function, you have to convert it to exponential. So converted this to exponential, there's a -1 in front of the log. So that means I have to divide by 1. So I have -y positive log of 6 of x plus 2. Now that there is no more, there's no value in front of the log, you can actually now convert from log to exponential. But I had to get rid of this negative here by dividing everything by -1. So that makes y negative. So converting it, I'll have 6 to the power of -y is equal to x plus 2. And then I can subtract 2. 6 to the power of -y minus 2 is equal to x. Now you have to create a table. X. And then you have y. So when you do these problems, you're gonna have to go backwards. Usually you always plug in x to solve for y. Now you're going backwards. You're gonna plug in y to solve for x. So backwards. So in this case, the easiest problem coordinate to always plug in is 0 for y. So in this case, when I have 0 for y, 6 to the power of -0 minus 2 will give me x. So 6 to the power of negative 0 is just 1. 1 minus 2 is equal to negative 1.
Negative zero, should we flip it?
What?
I said maybe negative zero, should we flip it?
You still get 1 no matter what. You're not wrong though. You're not wrong. You could do 1 over 6 to the power of 0, but then that 0 will become a 1. So it's 1 divided by 1, which is 1. I mean, yeah, I mean, if you wanted, you definitely can. And then I always say you always want to put one coordinate on the left-hand side and the right-hand side of your intercept. So if I have negative 1, 0, I should plug in negative 1 and positive 1. Okay, so I'll do negative 1 first. So 6 negative 1 minus 2 equals x. That makes it, oops, positive 1, which will give me 4. So that's another coordinate I can plug in. Negative 1 comma 4. And then the one coordinate on the right-hand side of 0, which in this case, it's going to be positive 1. So 6 negative 1 minus 2, oops, sorry. Minus 1 minus 2 equals x. Negative 1. That's 1, 6 minus 2. Since we're graphing it, you don't necessarily need to keep it as a fraction. You could write this as a decimal. So 1 divided by 6 minus 2 is negative 1.83. So you're going to have to go backwards. I'll give you guys a minute to copy these down. I'm not a fond of graphing logarithm functions. They're not hard, they're just tedious, especially when you're trying to graph it by hand. And then when you're graphing, technically, when you're graphing logarithm or exponential, you only need 2 coordinates to graph it, but having a third one is never too bad. All right, so let's graph it. So negative 1, 0. That would be right here. Negative 1.83, negative 1. And then we have, I feel like I'm graphing this wrong. Negative 1, 0. 4, negative 1. So that would be right here. This is incorrect. Negative 1.83, positive 1.
Yeah. I know.
So in this case, so these are coordinates, right? Negative 1, 0, 4, negative 1, and then negative 1.83, comma 1, right? Those are coordinates. Okay, so negative 1, 0 is right here, right? Negative 1.83, positive 1 is right here, and then positive 4, negative 1 is here. You guys see it? You guys see it? So, one thing I did forget is the asymptote, the vertical asymptote. In this case, your asymptote is depending on the x plus 2. Very good. So the domain is x is greater than negative 2. So then my asymptote is x is equal to negative 2. So there's a difference. The domain means x has to be greater than negative 2, but my asymptote is that x is equal to negative 2. If you guys remember from transformations, that x plus 2 means I'm shifting my graph to the left, right? 2 units. So that's pretty much the exact same thing. Let me fix this. X plus 2 greater than -2. So I subtract 2, so x is greater than -2 as my domain. And I have an asymptote at x is greater than or equal to -2. So I'm going to draw my asymptote. Like so. And then all I have to do now is just draw it like so. And that would be my graph. And then my intercept. Oops. It's at -1, 0, which is this one right here. And I have a perfectly good looking X logarithm graph. Does anyone have any questions? Unfortunately not. So they're not hard. It's just tedious, honestly. Okay, let's move on. Was that it? Oh shoot, no, it's more. A natural logarithm. Honestly, the exact same thing as logarithm functions. The only thing is that these are natural log. So this is E. Um, they share the same rules. On how to convert from exponential to natural logarithm. One thing you gotta know is if you have a log and the base is e, it's a natural log, so it's ln of x. So log of e of x is equal to ln of x. So this is on your calculator. Um, a couple things to note. If you have ln of e, this is always equal to +1 because log of e is equal to 1. So a couple things, ln of 1 is 0, ln of e is 1, ln of e of x is equal to e of to the power of element x equal to x. So this is the power rule, same as the previous one. You could just bring this to up, the power rule, so just bring it up. And then if ln x equal to ln of y, then x is equal to y. All right, use property of natural logarithms to write the expression. So e is equal to ln of e. We know that ln of e is equal to 1. So this is just -1. You are gonna have to do these without a calculator, so you kind of have to know the expressions. You can use a calculator to double check your work, but you gotta solve these without a calculator. You can use a calculator to check your work though. The next one, ln of e equal to 0. We know that e of 0 is just 1. And we know that ln of 1 is 0, so 7 times 0 is just 0.
Why is there so much space? Do you notice it in the homework day section? It's like funky.
Huh?
Why is there so much space? The natural log and the e, the 7. Throw me off. Wait, oh, usually it's like right next to each other.
Yeah, I guess you're right. I don't know why.
Weird.
Oh, I think because they didn't want you to get confused with 71.
Now that
Because I can definitely see this one be like that.
that's weird. That's weird. Oh,
Huh?
a single word, parentheses.
Yeah.
I think parentheses is better than just adding a space.
Right, because that's also the reason why they also put a space between the E and the N, because they're both variables. Yeah, it's like another word exactly. So that's why they put the spaces there. But technically, yeah, you could use parentheses. So that's one way to solve it, and then you'll know that there's more than one way to solve these problems. So another example, using the same problem, but solving it a different way. We know that ln can be also written as log of e, because that's natural logarithm, and e to the power of 0 is just 1. And no, it goes back to the same thing. Actually, never mind. I thought there was another way of solving it, but there isn't. It's just the same way. I don't know why I solved it that way. Okay. All right, that's it. That is pretty much it. You're not gonna be graphing natural logarithms today, but you might next week. I'm double check, but only logarithm functions. But that is it. That is today's lesson.